And the first problem here is a good example of what I mean by that. What if I just give you the following? 1 over the square root of negative 5. 1 over the square root of negative 5. We all know by now we can take the square root of negative numbers by using the idea of imaginary numbers. So on the top we'll have a 1. We'll have the square root of the negative, it'll come out as an I. We'll have a square root of 5 left over. But the problem is this is not simplified either because we don't like the I in the bottom and we don't like the square root of 5 in the bottom. So what I want to do is first I want to show you how to get rid of the I. And then whatever's left over, I'm going to show you how to get rid of the radical. And then in the future problems here, we're going to do both of them at the same time. We'll kill the radical and kill the I at the same time. But first, let's just deal with the imaginary number. We have I times the square root of 5. What do? We multiply by the I, right? We can just multiply by I on the top and I on the bottom. Now on the top, we multiply I times 1, we're just going to get I. We multiply I times this, we're going to get I squared times the square root of 5. But you all now know that I squared is negative 1, so we have negative square root of 5, like this. And of course, you know when you have a negative sign, it can float in front of the fraction and so on. So what we really have here is negative I over root 5. Now, typically we would say this is the final answer. However, we don't like this radical here in the bottom. And we already learned in previous lessons how to get rid of the radical. Well, we take what we start with, negative I square root 5, and we multiply by what? By the radical on the top and also the radical on the bottom. And so we do the multiplication. I times the square root of 5, we have the negative sign in front, is I square root 5. On the bottom, we have the square root of 5 times 5, square root of 25. And so now you know the negative will be here. We'll have I radical 5. And here the square root of 25 is just 5. This is the final answer. I times square root of 5 over 5. So it looks like this is more complicated than this. But typically, this is what we will circle and say is the most simplified version of everything. Yes, it has a negative sign. That's ugly. Yes, it has a little more complicated numerator, but this is what we want. We don't want any radicals in the bottom, and we don't want any imaginary numbers in the bottom. Now, in this case, we killed the imaginary number by multiplying by this, and then later on we killed the radical by multiplying by this. In the future problems here, we're going to do both of those at the same time. So for instance, if we have 18, square root of 18, and on the bottom we have really complicated looking guy, 2 times I times the square root of 6, for instance, how would we simplify that? So we have this square root of 6, and then we also have an I, we don't want that, and we have this radical we need to simplify. So let's go off to the side and deal with the 18. So we have an 18, and we can say that that's 9 times 2 is 18, and 9 is 3 times 3. And we're looking for pairs. So there's my pair. So what I'm going to have in the numerator is a single 3 is going to come out. A square root of 2 is going to be left behind. Now in the bottom, I'm going to have 2 times I times the square root of 6. Now I don't want the I there, and I don't want the 6 there. So what do? I'm going to multiply this. Let me rewrite it actually. It's going to be 3 root 2 over 2I root 6. Now what I'm going to do is I'm going to multiply the top and bottom. I need to multiply by an I in order to get rid of the imaginary number I, but I also need to multiply by the square root of 6 to get rid of the radical. Now in the previous problem we did them separately, but here we're going to do them at the same time. So when we multiply numerators, we have a 3 times the I, giving me 3I. And for now, let's keep it clean. Let's say we're going to multiply the square root of 2 times square root of 6. We'll deal with that in the next step. Here we're going to have 2 times I, so we'll have 2 times I squared, and then we have the square root of 6 times the square root of 6. So let's just keep it like this. We're not going to do this every time, but in the beginning I want to make sure everybody's on the same page here. So what I'm going to have is, I'm going to have on the top 3I, 2 times 6 is 12, I can bring that under a single radical. 2I squared, you just replace it with negative 1. Anytime you see an I squared, replace it with a negative 1. And then I'll have the square root of 6 times 6 is 36, right? So on the top, what we have is 3I times the square root of 12. Now the square root of 12 can be simplified as well, so let's go do it over here. Let's just find some room here. 12, well, we have 3 times 4, and 4 is 2 times 2, so we circle the 2's. So what I can say is that the square root of 12 is equal to 2 times the square root of what's left over, which is just the 3. In the bottom, negative times 2 is negative 2. Square root of 36 is just 6. And now I can finally write the whole thing. Right, now you can actually see the 2's are going to cancel, but let's just go ahead and multiply everything out to show. 3 times 2 is 6, so I'm going to have 6 times I square root of 3. On the bottom, actually what I want to do here is I'm going to take this negative and float it out in front of the fraction. On the bottom, 2 times 6 is 12. And you can see I have a 6 and a 12. So what I'm going to do is divide both by 6. 6 divided by 6 is 1, so it's going to basically disappear. And 12 divided by 6 is 2. So the answer is negative I times the square root of 3 over 2. Now actually, in the previous step, notice we had a 2 in the front and a 2 here. And you can see right away they're going to cancel. Then you have a 3i in the front, and you'll have a 6 in the bottom. So 3 over 6, you can reduce that to 1/2, and that's what you get here. So whether or not you simplify it here or you just multiply and do it at the end, you're going to get the same answer. And even though this looks perhaps more complicated to some people than this, maybe not, it looks a little better to me, but it doesn't really matter about what it looks like. What you need to do is have no radicals and no imaginary numbers in the bottom, and that's what we've done. All right? All right, cruising right along. We're just going to get a little more complicated as we go. None of these are difficult, but they do require us to take our time. Square root of 60 over the square root of negative 15. All right, we know how to deal with the square root of 60, so we come over here and say, well, what does 60 equal to? 60 can be written lots of ways. 6 times, let's do 10, and then this is 3 times 2, and then 10 is 2 times 5. And you can see I have a pair of 2's right there. So I can, of course, pull that pair of 2's out as a single. And so on the top, it's going to be a 2 times the square root of what's left over. 3 times 5 is 15. That's what's left over, so that goes under the radical. And then I have a square root of 15, but I can't simplify it because 3 times 5 is 15, and I don't have any pairs. So I'm going to have a square root of 15 here, but I have to write an I in front because the square root of the negative 1 comes out as I, and what's left over under the radical is what's left over, of course. Now you can see what's going on. Interestingly, this entire square root of 15 cancels with this entire square root of 15 as a quantity. So what I end up having is just 2 over I. Now you might be tempted to leave that alone, but you realize I don't want any i's in the bottom. So I say, well, I'm going to multiply by I over I. So on the top I'll have 2 times I, and the bottom I'll have I squared, I times I. But then I know that that's 2 times I over this, which is just negative 1, and 2 divided by negative 1 is just going to be negative 2i. So the final answer is negative 2i. In my humble opinion, these problems are actually a little bit fun. The only thing you have to realize is you treat I as a variable in terms of squaring in and combining terms. But anytime you have an I squared, you have to replace it with a negative 1. If you can remember those 2 rules, then you'll be able to do anything you want with imaginary numbers. Any kind of multiplication, any kind of solving equations, anything like that. Which brings me to the next problem. We're going to solve our very simple equation. We open this whole thing by saying some equations require imaginary numbers to solve. Now, it doesn't look like there's any solution to this equation. Why? Because anything I put in here, let's change that a little bit. Any real number I put in here, like negative 2, square it, I'm going to get a positive number. If I put a positive number, I'm going to square it, get a positive number. There is no real number I can put here and square it so that I can add it to 144 and get 0. That's why there's no real solution to this. In the past, we would say there's no solution to that. But now we know about imaginary numbers, and there is a solution to it that involves imaginary numbers. So the way you do it is just like always. Move the 144 to the other side, making it negative 144. And to kill this x squared, we have to take the square root of both sides. When we do that, we have to put a plus or minus, and then we have negative 144. Now, you all probably know that the square root of 144 is 12. And so what you have is the square root of the negative 1, which is an I. So what you have is plus or minus 12 times I. That's what you have here. So what this really means is that x is 12i, and x is negative 12i. There's 2 solutions, but both of them are imaginary. Now, let's take a look and see why this equation does have a solution if you consider imaginary numbers solution in your solution space or possibilities. If you take 12i and stick it in here and square it, what are you going to get? The 12 times 12 is 144, but the I times I is going to give you negative 1. So it'd be negative 144, which adds with this to give you 0. If you take this one and put it in, if you take this times itself, the negatives are going to give you positive. Negative times negative is positive. The 12 times 12 is going to give you the 144, but the I times I will give you negative 1. So really it'll be negative 144 plus this will give you 0. So you see there are solutions to these things, but they involve imaginary numbers. All right? And we already talked about why they're useful. They're useful because they allow us to solve certain equations. Now, you might not care if this equation has 12i and negative 12i, but I'm just telling you now, there are equations we study in more advanced math that give you imaginary numbers that you can then use, usually when combining with other things, that will give you real results. So the solutions to these, even though they're not real, it doesn't mean they're useless. It just means that I can't hold 12i apple pies in my hand, but I might be able to combine that 12i with 4i from some other problem I have, and then I get something real, right? So then, another equation, very simple. 2 times w squared is negative 98. How would I solve this? Well, just pretend you don't care about negatives. Divide by 2. W squared, negative 98 over 2. So w squared is negative 49. And I want to solve for w, right? So it's going to be plus or minus. I have to take the square root of both sides, negative 49. In the past, we would stop and say, well, we don't have the square root of negative. But now you know better. You're going to get plus or minus. 7 times 7 is 49, and then you have the square root of the negative 1, giving you 7i. But there's two answers. What you really have found out is that w is 7i, and w is negative 7i, right? So again, this guy, you would think wouldn't have any solution, because if I square any real number, I'm going to get a positive answer that I can multiply here. There's no way it would ever be able to equal a negative number. But if you stick an imaginary number in here, then the 7i squared will give me 49 times negative 1, be negative 49. Negative 49 times this will give me negative 98, so it works. Same thing's going to happen if you put this one in. So the reason that we can do this is precisely because I squared is equal to negative 1. Okay, last problem we have for this lesson is 3 times u squared plus 40 is equal to 4, like this. So we want to solve for u. We're going to subtract 40. 4 minus 40 is going to be negative 36. And I'm going to divide by 3, negative 36 over 3. So what I'm going to have is u squared is negative. What's 36 divided by 3? It's going to be negative 12. And so to solve for this, I'm going to have to take the square root of both sides. U is plus or minus the square root of negative 12. I come over here and I write a 12 down, do a factor tree for it. 3 times 4 and 2 times 2. Here's my pair. So as far as the radical part goes, a 2 is going to come out, and I'm going to have a leftover a square root of 3. But the square root of this negative 1 pops out as an I. So the answer is 2 times I times the square root of 3. Again, there are two solutions. Positive 2i square root of 3, and also negative 2i times the square root of 3. Right? And if you were to take it, I'm not going to do it, but if you take either one of those and put it in here and multiply it all through, the radical, you're going to have to square that radical and so on and add it up. Both of these solutions are going to work. But it doesn't look like there'd be a solution at first, because any real number you put in here is going to give you a positive number for this, which will never be able to add with this and give you 4. It's because when you can stick imaginary numbers in, you square them, you get negative numbers. That's why you can add it to 40 and get a smaller number out. All right, so we're just building our skills. This is more of a skill builder section. You know, I can tell you all about imaginary numbers, and I can tell you how easy they are to work with. But until you actually do them, you're not going to really understand or get that for yourself. So these are good intermediate level problems. We have 2 more lessons in simplifying expressions with imaginary numbers. Follow me onto those right now. We'll get more practice with more complicated problems. Learn anything at mathandscience.com.